Hi guys, welcome to our review of Chapter 13. Today should be Wednesday, May 16th. So we're reviewing Chapter 13 for your finals next week, or this week if you're 7th period, because remember your finals for 7th period are on Friday. So let's go ahead and walk through some examples for Chapter 13. Remember, you will have a quiz on Chapter 13 material tomorrow, so be ready for that. So here we go. Question number 1, we're going to expand this. If you remember back to when we did this, we started by pointing out all of the properties that were going on. So we've got product there because there's multiplication. We've got power here. We've got a quotient rule because of that division. And then we have product. And then, ran out of room, power again. And when you're expanding, you go opposite order of operations. So the last thing we would be doing if we were actually calculating this is that quotient rule. So that's going to be the first thing we take care of. And division, remember, turns into subtraction. So when I write this as 2 logs, I'm going to have my numerator, and then it's minus my denominator. Cool, so we took care of that quotient rule, and then I'm going to take care of the product rule, I'm going to take care of the product rules all at the same time, so there's multiplication going on here, and when we split that into 2 different longs, it'll turn into addition. So I'm going to say log 3 5 plus log x squared minus, and then do the same thing over here. That multiplication will turn into addition when we separate it. Okay, and then the only thing we haven't taken care of from our list up here are those power rules. And remember that power rules are the easiest to take care of because we're just taking this exponent and throwing it in front. And so same here, we'll take this exponent and throw it in front. Remember, those exponents can only jump 1 log. Right, so it's not going in front of this whole thing, it's just going in front of that log that it's attached to. So when I do that, I'll have log base 3 5 plus 2 log base 3. Oh, I lost my 3 over here. Yeah, our bases don't change. X minus log base 3 2 plus 5 log base 3y. I do kind of want to just go through some of those properties, like the ones that we use when we expand or condense logs. So these are basically all of them, but just so we have a nice list going, and you can include this in your notes. That the product rule says that multiplication turns into addition. The quotient rule says that division turns into subtraction. And then the power rule is kind of a weird one to write, I think, but that the exponent turns into multiplication. Awesome. So we're going to use those in the next problem, but we're going the other direction. So we're starting with something that is completely expanded, and we're condensing it. I'll stick with the pink pen. So I see here that that's a power rule. It's multiplication now, but at some point it was an exponent. This is addition, so that must be a product rule. This is subtraction, so it must be a quotient rule. And then again, we have another power rule going on here. And then backwards from this is going to go in our order of operations, right? This is going to use PEMDAS. So the first thing we should take care of is that multiplication. So the first thing we're going to take care of is the power rule. So this is going to become an exponent, and so is this 7. So I've got log base 6 x to the 4th. Oh, I missed one. This is another power rule. Plus log base 6 y squared, because this 2 becomes an exponent on the y, minus 7 log base 6. Just kidding. We said we'd move that, didn't we? To an exponent on the x. Alright, and then moving from left to right, I'm going to take care of first the product rule, so that will turn into multiplication. So I've got log base 6 x to the 4th y to the 2nd, and I still have the other one. And then the last thing to take care of is the quotient. That subtraction will turn into division. And so when I go over here to write my final answer, I've got log base 6. The first argument, this part, is my numerator, and divided by the second argument will be my denominator. Okay, so there we have an example of both expanding here to here, and then writing as a single log, right, condensing it from here to here. So that was like the first half of chapter 13, and the second half was using logs to solve either exponential or log equations. So this first one here is an exponential equation, and so I'm trying to solve for x. Well, the first thing I need to do is get that base and exponent by itself, right? So I need to get this alone. So I'm going to move the 7 over. It's plus 7, so I'm going to subtract 7. And 259 minus 7. Alright, and then a few times in chapter 12 we got ourselves stuck here where we couldn't solve for an exponent, and so that's why we introduced logs. So logs will help us solve for exponents. So I'm going to rewrite this as a log. Remember that it's up on the red poster in the room, so if you're in the room right now you can look at the red poster. But we have bx equals a as our exponential will turn into log base b a equals x, right? So here I'm going from here to here, but this also works backwards. So my base is 6, so I've got log base 6. My argument, or my answer, is 252, and that equals my exponent, right? So my exponent in this case is that whole thing, x minus 5. And we learned something, you can look back in your notes for this, like some more review on this, but we learned change of base. And so I'm going to apply change of base here in order to make this a number, because our calculators only know log base e and log base 10. They don't know log base 6. So we're going to do that now. Log of our argument, right? So log 252 divided by log of our base. In this case, that's 6. Now, hopefully we can see this. Please follow along on your calculator so you make sure you know what, how to do what it is we're doing. So I'm going to type this in. The log button is right next to the 7. Hitting that. I'm doing 252, closing my parentheses, divided by log again, but this time of 6, and I get just a number. And we can round to 9. And that's great. That solves this part, but that equaled not x, but x minus 5. So we're right there, and to solve for x, we'll just add 5 to that. Cool. That was a lot. So here are the parts that maybe you should be like looking back in your notes to remember how to do. We've got ooh, that doesn't work. we've got this part, right, writing exponentials and logs and going back and forth, and then also look up change of base and just get a few more examples of change of base so you can just get some practice with it and practice typing it in to your calculator. Awesome, so we've got one more to do. Let me readjust here. Alright, so now we're kind of going backwards. Like up here we had an exponential and we used logs to solve it. Now we have a log. My guess is that we'll end up as an exponential to solve it. But let's see. So we've got two logs that are being added. So the first thing I need to do is write this as a single log. Now if you remember, that's a product rule, right? It's addition, so it's going to turn into multiplication. So I'm going to do that now. Log base 6, and so I'll do x times, because that was my first argument, times my second argument of x plus 5. Great, now I can get rid of that log, which will be pretty easy because I'm just using this again, right? So I've got log base 6, so my base here is going to be 6. And then my exponent is whatever the log is equal to, so in this case 2. And then this whole argument is what that equals. Alright, I'm going to do two things in one step here. So first I'm going to do 6 squared, so I know that 6 times 6 is 36. And I'm also going to distribute this, so x times x is x squared. And I've got x times 5, so 5x. Now I'm noticing that I have an x term and an x squared term, right? I've got two terms that have x in them, so I'm going to guess that I have to factor. Before I can factor, I have to set it equal to 0, right? So I have to move this 36 over to the other side so that there's just 0 over here. I'm going to subtract 36 from both sides. So 36 minus 36 gets me 0. And then I don't have any like terms here, so I'm just going to rewrite this whole thing out. Squared plus 5x minus 36. Alright, now we have to factor. So factoring this is super duper easy because there is no term, like there is no value in front, right? There's no leading coefficient. It's just 1. So it's really easy. We're just going to see what multiplies to 36 and adds to 5. So let me make my list. Some of you are like really strong at factoring and you see it already, and others are not. So I'm just making my list of things that are that will multiply to 36. And there's a bunch. I think that's it. So then I'm looking for which of these pairs will add or subtract to 5. And I notice that this one will do that. 4 and 9. So I'm going to open two sets of parentheses. X, X. And we got 4 here and 9 here. Now I need it to add to a positive 9, or positive 5. Right? Which means that my 9 has to be positive and my 4 has to be negative. So that when I do negative 4 plus positive 9, I will get a positive 5. All still equals 0. And so then we get two answers here. We get, if we add 4 to both sides over here, we get x equals 4. And if we subtract 9 from both sides over here, we get x equals negative 9. So we've got two answers. Now remember, from logs, this is way back in our memories, that the argument, right, of our original cannot be negative. So I might want to write that down. Argument cannot be negative. So when I look at these two answers, if I was to plug in 4, I'd be fine, because then that would be 4 here. And 4 plus 5 would give me a positive 9, so that's not a problem. But if I plugged in a negative 9, I would get a negative 9 in this argument. and even here, a -4, right? So this cannot happen. That cannot be our answer, and our only answer is 4. And that is it. That is all I have for chapter 13. So again, we talked about the properties of logarithms. We talked about writing from exponential to a log, talking about our change of base here, and then also how we check for extraneous solutions for logs, noting that our argument cannot be negative. I'm just looking through your quiz for tomorrow, seeing if there's anything else you should look at. The only other thing that I think might be helpful for you to do is look at some problems from 13.5, I think. And the things I'm talking about for 13.5 are like the pH equation, the population equation, right? Those sorts of things, like using it like given equations to solve. So make sure that you look there, because those sorts of things are on your quiz tomorrow. For the most part, they're pretty easy. They're just like noting what represents what and plugging them into appropriately into the equation. So, all right. So good luck. Work hard on your study guide for chapter 13, and we will have that chapter 13 quiz tomorrow.